All right. So, exam one just around the corner, and it is time to do some reviewing. So, your exam one, just to kind of talk to you about it, because this is in the online math resources course. Obviously, all of you should probably be enrolled in this already. That's how you got here. But I want to show you where this material is at if you haven't explored it. So right here is the intermediate algebra course. Open it up. And then right over here is the test review materials. So in here, when you click on it, there are 3 tabs. Okay. These are the old test reviews for iMath AS. Okay. So if you're in an iMath AS, I highly advise you to look at these. But we are in My Math Lab. So you're going to click on the My Math Lab reviews. And because this is really our first year doing that in the fall of 2020, we're creating all of the version A's this semester. So here is the blank review. Here is an answer key, but it will soon be updated because we are going to work on the full worked out solution guide right here together. Okay. And so that will get replaced with the full worked out solution guide. And then this is where the video we are creating right now will go. Okay. So anytime after this, if you want to come back and review, here's the blank review. Here is the answers right now, which will soon be a solution guide. And then that will be where the video is. So those of you that asked me earlier, was I supposed to print anything out? No, you can come right in here and you can open this up and you can take a look at it. I mean, that would be a horrible view. But the other thing you could do, because that's actually small, is you can click on it and you can download this to your desktop and then open it from there. Okay. So that's the review, and I have it right here already for us. So you don't technically have to have it up on your computer because I'm going to show you that review here in just a moment. The exam you're going to be taking, it looks like it's kind of multiple choice, but some of these you do have to work out your solutions. Everything that is on this will be just like your exam when you take it in your course. Okay, pretty much should be the same order, should be the same types of questions. There should be no surprises if you review this and then review the exam that you do in your course. Okay, there are a total of 20 questions. All right, so let's get this party started and let's start going through this exam. I'm gonna get rid of some of my other tabs so that way my computer doesn't lag too much. Okay. So question number 1. Oops. It is a compound inequality. What kind of compound inequality is this? This is where you all interact with me.
And?
You got it right there. It says and. It's an and. Remember, compound inequalities are ands or ors. Where do ands shade normally?
In between?
In the middle, in between. It's like a pinball. You're stuck between 2 numbers. So I'm writing down the problem real quick. So we want to solve this. Okay. And the answer is going to be in interval notation if it exists. So not set notation, but interval notation. And as always, I can't hype this enough, always make sure that you read that fine print either after the blank or below the blank that's in blue. So that way you know how you put your answers in. Because right here you can see it says use integers or fractions. So that means no decimals are allowed in this answer. Always make sure that you're reading that information very, very carefully. All right, so let's solve this problem. So how am I going to solve x plus 10 greater than or equal to 8? What are we going to do?
Subtract.
You're gonna bring over the 10.
Yes, there we go. Subtraction. Yes, you both got it right. Combine the two answers, and we're doing great. So we got x greater than or equal to 8 minus 10, negative 2. So there's one piece of our answer. All right, now let's come over to the second inequality. 8x minus 2 greater than or equal to 6. How do we solve this?
You're gonna have 2 on both sides.
We're going to add 2 on both sides. Perfect. So 8x greater than or equal to 6 plus 2, 8. Now what?
Divide both sides by 8 to get x by itself.
Yay! So x is greater than or equal to, what is 8 divided by 8?
1.
1. Yay! All right. So now all we have to do is we need to look at a graph of this because we want to make sure that it shades in the middle. We can't automatically assume it does. So we need to look at a graph. So remember, I keep my graph simple. I don't put a lot of stuff on it. What number is going to go down here on my left dash?
1.
Say it again.
1.
Nope.
-2.
-2, because that's the smallest. Remember, this should be the smallest number. Then over here is the number 1, because 1 is bigger than -2. All right. So we're going to take x greater than or equal to -2, and I'm going to graph that above the line. So is this going to be a bracket or parenthesis at -2?
Bracket.
Good. Do we shade to the right or to the left?
Right.
To the right. Follow the arrow. So that right there looks like this on a graph. It's a bracket because it's an equal to. All right. Bracket or parenthesis at 1?
Bracket.
Shade to the left or shade to the right?
Straight to the right.
Shade to the right. So I'm just going to put it above it. Okay. Now, there's what our graph looks like. Well, at least above it. Ands usually shade in the middle. But overall, what do ands really want?
Where the 2 lines meet.
Where the two, not necessarily where they meet, but where they overlap. Okay? So where on my graph up here will the shading overlap?
1.
At 1. So is it a bracket or parenthesis at 1?
Bracket.
Bracket, because it keeps the sign. And shade to the right or to the left? I actually kind of gave that away.
Right.
Shade to the right, because that's where both of the shadings occur, right in here. And that's what ands want. They want wherever both of the shading is. So we can see this is not one of those that shades in the middle. This is one of those special ones. Okay? Now the question is, what does this answer look like in interval notation now?
Isn't it 1 infinity?
1 to infinity, good. So 1 comma infinity, bracket or parenthesis at the 1?
Bracket.
Bracket, because it matches. Bracket or parenthesis at infinity?
Parentheses.
And there is the interval notation. So you will be selecting A. So you'll select A, and then you'll come over here and you'll put the bracket 1 comma infinity parenthesis. Does that make sense?
Yeah.
Okay. All right, number 2. Notice number 2 is also another compound inequality. Is this an and or an or?
Or.
Or, because it says or between the two. Now, where do ors usually shade?
Both on the outside.
Usually the outsides, okay? Usually the outsides when we graph it. But again, it could do something weird. So I've got our inequalities. So how do I solve x plus 6 less than 0?
-6 on each side.
Minus 6 on each side. So x less than 0 minus 6 is a negative 6. Okay, so there's part of our answer. How am I going to solve 3x greater than negative 15?
Divide 3 by both sides.
Okay, so divide by 3, divide by 3. X, what's negative 15 divided by 3?
5.
All right, now the question is, does it stay greater than or does it flip to the less than?
It flipped.
It does not flip. It stays greater than. Remember, it's all about if you're dividing or multiplying by a negative. This number down here is not negative. We don't care what the numerator does. We care about the denominator when we divide on this. This is a positive number. Leave the sign alone. So be careful of that. Okay? So the sign actually stayed the way it was on this. All right, so all we got to do now, graph. What number goes up my left dash?
-5.
No.
-6.
Negative 6. Careful on your numbers, guys. That's one of those things that it will kick your booty if you're not careful. And then the next the largest number is our -5. Okay? All right, now let's graph x less than -6. So is this going to be a bracket or a parenthesis at -6?
Parentheses.
It's going to be a parenthesis. Good. Now, shade to the left or to the right?
To the left.
Okay. So there we go. Bracket or parenthesis at -5?
Parentheses.
Left or right?
To the right.
Okay. So notice this is doing exactly what an OR does. Because where do ORs shade? To the outsides. And the reason why ORs usually shade to the outside, because what are ORs really after overall? What do ORs really want?
I don't remember.
You don't remember? That's all right. Anybody else remember? What do ORs really want?
Wants all shading.
Yeah, all the shading. So wherever there is shading, that's the answer. So we're going to have the parenthesis shaded to the right of -5. We're going to have the parenthesis shaded to the left of -6 because that's where all the shading is. Okay. So let us get our answers to this. Remember when we write up our inequality or our interval note answers, it's just like writing two intervals. Like you guys wrote this one because there was only one, but it's the same thing. We're going to write this interval, then we'll write this interval, and what will go between it?
Union.
Union. All right, so good. Let's write this interval right here. So what does this interval look like?
-∞, -6.
Okay. Because this arrow represents -infinity and it goes up to -6. Bracket or parenthesis at -infinity?
Parentheses.
Bracket or parenthesis at -6?
Parentheses.
Okay. Let's write the second interval. What does this one look like?
-5, infinity.
Okay. Bracket or parenthesis at -5?
Bracket. Parentheses. Sorry.
Parenthesis. Bracket or parenthesis at infinity?
Parentheses.
And again, what goes in the middle?
Union.
Union, which looks like a capital U. And there's the answer. That's what they want. So you'll come into your, excuse me, exam, you'll click A, and you will put that in there. Now, please be careful on the union symbol. Do not use a capital U. It will count it wrong. And then you're going to be emailing me going, this I'm going to count it wrong because I used a capital U and I didn't listen to you and things like that. I don't know how your professors are going to be, but I will be like, I'm sorry because I keep warning you about that. This is what we call calling attention to precision. Make sure that you are using the correct symbols, okay? My math lab will provide a symbol for you for union that you have to use. Please make sure that you do not use a capital U, that you use the union symbol provided by my math lab. Can't stress that enough. All right, moving on. Number 3. Numero 3. What is problem 3 about?
Absolute value.
Absolute value, our best friend. How many answers do absolute values have?
2.
2. And the rest of you, feel free to shout out answers too. Rochelle, I know you all know this. Rochelle's not the only one. All right. So let's talk about how we get this answer. So there are 2 answers, which means that we are dealing with 2 equations. You're all really good at giving me equation 1, but it's equation 2 that kicks your booty sometimes. Sometimes. So let's talk. What does equation 1 look like for this absolute value?
You're bringing it down. You're just dropping the absolute value signs.
Yeah, Kiki. So 2x minus 7 equal to 11. All you're going to do is drop those absolute value signs. Drop it like it's hot. See? Easy. Okay, so drop those absolute value signs. What does the second equation look like?
2x minus 7 equal negative 11.
Yes, yes. Drop the absolute value signs. Make the right side the opposite sign. So since this was a positive 11, we made it negative 11. That's how you get the second equation. Drop the absolute values. Make the right side the opposite sign. Okay. So how do we solve 2x minus 7 equal to 11? What are we going to do first?
Add 7 on both sides.
Yay! So we get 2x equal to 11 plus 7 is 18. Now what?
You
You're gonna
divide.
divide by 2.
Yes, divide by dose, divide by dose. X equals 18 divided by 2 is?
Want me to cut it?
18 divided by 2 is?
9.
9. There we go. So there's one of our answers. All right, now over here, 2x minus 7 equals negative 11. How do we solve that one?
You're gonna
Add
add
7 on both
Yeah. So 2x is equal to negative 11 plus 7 is?
18, negative 18.
How about negative 4? Careful. Negative 11 plus 7.
negative 4.
Yeah. And then you divide by 2. Notice that when you're solving the absolute value, the same steps that you did over here are the same steps that you do over here. It's just a different number on that right side. So x is equal to negative
2.
2. So all you're going to do is come into your exam. You're going to click A. And then you're going to come over here and you're going to put the 2 numbers in, separated by a comma. Okay? So in your exam, it would look like this. And I always put the smaller number first and then the larger number. So that's what it would look like on your exam. But if you put 9 comma negative 2, it's the same. It is the exact same. It will not count it wrong because it doesn't say anything about the order. But just so you know, whenever you write a set, You put them in order from smallest to largest. Okay. Moving on, number 4. So number 4, we are graphing. They want us to graph this, and notice the directions. They're very specific about the graph. It says graph the linear function by the x and y intercepts. Graph the function by the x and y intercepts. Okay. Let me double check something. Okay. Just wanted to look at something real quick. All right. So how am I going to graph this? How do I find the x-intercept and the y-intercept to this?
Add 3x on both, minus 3x on both sides.
Nope. You're trying to put it in the slope-intercept form. There's an easier way. We want the intercepts, Rochelle.
This is where we can do the cover up, right?
Yes, Kiki. When you're in standard form and you want x and y intercepts, just do the cover up that I talked to you about in class. So if we want the x-intercept, who do you cover up?
The y.
The y, because remember that the x-intercept is a number, comma 0. And we can cover up the y because it is 0. So you go, bam! What's left?
Gonna divide 3 to both sides.
Yeah, because you got 3x equal to 6. So we covered up that y information. We had 3x equal to 6. Divide by 3, divide by 3. X is equal to?
2.
2. So that's your x-intercept. 2, comma 0. If we want the y-intercept, who do we cover up?
X.
X. Because again, you got 0, comma, a number. And we can cover up the x because x is 0. So that gives us, bam, what's negative 6y equal to 6? What do we do now?
Divide both sides by negative 6.
Yay! Y equals what?
1.
Negative 1. So now you know the y-intercept, 0, comma, negative 1. And you can graph. So I'm just going to make a makeshift graph over here. And it doesn't have to be a very big graph. So when you get into my math lab, remember that once you click on the graph, remember there's going to be a toolbar that shows up below it. Okay? So once we click on this graph, click, there's a toolbar that shows up below. And you've got this tool that's like an arrow for your selecting. You've got a line tool that has like 2 dots on it. And then you got lots of other tools that follow behind it, so on and so forth. So all you have to do is click the line tool and then plot these 2 points. Okay? So you click the line tool, you come up, you plot 2, 0, click. As soon as my mouse moves away from this, you'll see the line following your mouse wherever it's at. And then you're going to click 0, negative 1. And then the line will form. Okay? And you have to use the intercepts on this because the directions say use the intercepts. Any questions about number 4? That is the correct graph. Okay? Yes. Good. I'm glad you all agree. All right. Number 5 Z's. So they've given us this equation, Negative 7x plus y equal to 11. There's two questions. They want to know what is the slope and what is the y-intercept. So they, in other words, they want to know what is m and what is b. How can we figure that out?
Hmm?
How can we figure out the slope and the y-intercept to this?
Oh, you add 7x on both sides.
There we go. This, Rochelle, is where you want to convert. Okay? So just rewriting over here so we can do some work so it's not crunched right here. So add 7x to both sides. Perfect. Are these two going to get together, the 7x and the 11?
No, separate.
No. So you can either write 7x plus 11, or remember that you could have written 11 plus 7x. And generally there is one more step, because what number is in front of y?
1.
There's a 1. So generally the last step is to divide all the numbers by the number in front of y. But the number in front of y is 1. Will that change anything if I divide by 1?
Mm.
No. So you can divide by 1 if you want, but your answer is still going to be y equals 7x plus 11. So what is the slope of this line?
7.
7. What is the intercept of the line?
11.
There you go. So we're going to come back to our test. Right here, you're going to put 7. Now down here, look at what this says. What kind of answer does it want?
An ordered pair.
What is an ordered pair? What's another name for that? It's a P word. Because this is not an ordered pair. What is an ordered pair? Or does anybody know what it looks like as an ordered pair? And you can tell me that.
Isn't it just the 2 points?
Not 2 points, but it is just the point. What is this as a point? Remember that B represents the y-intercept.
7, 11.
Say it again.
Wouldn't it be 7, 11?
No. Y-intercept
0,11.
0, 11. Y-intercept. Remember, y-intercept has 0 for x. The 7 is a slope. It's directions. It's not an actual point that you plot.
I got it now.
That is what they want in the blank. Ordered pair just means give me the point. So remember, it's a y-intercept. That means x is 0. That's the y value of the point. Everyone good?
Yeah.
Okay. All right. Question 6. They want to know, are these lines parallel or perpendicular? Or neither?
Hmm?
Parallel, perpendicular, or neither? How do we determine if lines are parallel, perpendicular, or neither? What information do we need?
We need to find the slope.
We need the slopes. So what is the slope for the
I'm not-
equation f?
-2.
Minus 2, a negative 2. What is the slope for the g function?
A half.
Now the question is, here are the slopes. Are they parallel, perpendicular, or neither? They're what?
I think one is parallel.
I think they're both parallel.
You think they're parallel? What does it mean when you have, oh, I should probably put M here. So what does it take to be parallel again? Do you remember? We talked about it earlier this week.
Exact same.
Say it again.
You have to have a denominator.
No. The key to being parallel, again, I think you were saying it, Stephanie.
The exact same.
They have to be the exact same. Are these the exact same?
Mm.
Huh?
No.
No, then they ain't parallel. This is a -2. This is a half. That's not the same. So the question is, are they perpendicular or are they neither?
Perpendicular, because when you flip the F, you're gonna get -2.
Yeah. Well, when you flip it, no, you don't get -2. The F?
No, the G.
Yes. All right. So remember, to be perpendicular, you are opposites, which means one is positive, one is negative. So we've got that. And that they are reciprocals. Reciprocal means flipped. What number is 2 over?
1.
So if I flip those, that gives me 1 over 2. These are perpendicular slopes because they are opposites. And the fractions are flipped because this is a fraction. It is over 1. Okay? All right. Number 7. So it says determine whether a line with the given slope slants upward, which means that it's positive, slants downward, which means that it's negative, or if it is horizontal or vertical. So the slope of 0. What do you think that line looks like? Will it increase from left to right? Decrease from left to right? Is it vertical? Is it horizontal?
Horizontal.
It is horizontal. So the answer is B. It is horizontal. So you would just come over here, select B, and move on with life. Be happy. What would a slope for vertical be? Just to kind of review.
One.
Say it again.
1.
Sorry, Rochelle, I'm not quite, it's a little muffled.
1.
1? Nope. What would the slope for vertical be? All vertical lines have this slope. It never changes. What is it?
Infinity.
It's not infinity. Because all these lines technically go to infinity. It's not infinity. It's a U word.
Undefined.
Undefined. All vertical lines have a slope of undefined. Okay? So if it was to slant upwards, that means the number would have to be positive. So someone give me a positive slope.
2.
2. There you go. If this said m equals 2, you would have selected slanted upward. Someone give me a slope that slants downward. What would that be then?
-2.
-2. So positive slopes slant upward. Negative slopes slant downward. Horizontal is always 0. Vertical is always undefined. Make sure you know that. All right, number 8. Let's write an equation.
Number 8.
So we've got these 2 points, -3, 7, and -1, 3. How are we going to write the equation to this?
Is it like y2 minus y1?
Yes, because what are you finding for me? You said y2 minus y1. Then what? Keep going. Keep going, Stephanie.
Over x2 minus x1.
Yeah, because you have to find what first?
Slope.
The slope. We need the slope first. Without the slope, we can't do anything. Okay? So
Let's see.
the negative 3, 7 is x what, y what? Is it ones or twos?
1.
Yeah, because it's the first point. Then that means this negative 1 and 3 are the x2, y2. So let's plug in. What's y2?
3.
Minus. What's y1?
7.
What's x2?
Negative 1.
Minus. What's x1?
Minus negative 3.
Yes, you need both of these. This first minus is because of the formula. This second negative is because of the number. You need both. All right. So what is 3 minus 7?
Negative 4.
What is negative 1 plus, because those turn into a plus, 3?
Positive 2.
So what is our slope?
Negative 2.
Okay. Now what are we going to do up here? I've got 2 points. Do I need both of them?
No, you choose one.
Choose one. All right. So let's get someone that hasn't said anything. Kelsey, I know you're in here. Kelsey, pick a point, girl. Pick a point for me, please.
-1 and 3.
Yeah, that's the one I would have went with. So we're going to go with this guy. And remember that I took you guys through what is called point slope, which point slope looks like y minus y1 equals m parenthesis x minus
So
x1. So all we got to do is plug in the y1, the m, and the x1 according to our slope and our point. So y minus, what's our y1?
3.
3 equals, what's our m?
Negative 2.
Parenthesis x minus, what's our x1?
Negative 1.
And again, you need both of those.
Uh-huh.
All right, so what are we going to do now?
You're gonna multiply 2 by the bracket.
Yes, we're going to take the 2 through the parenthesis. So we'll have y minus 3 equals, what's negative 2 times x?
Negative 2x.
Yay! And what is negative 2 times a positive 1? Because this will turn positive.
Negative 2.
Yay! And then I'm going to continue on to my next piece of paper. So 8. So we've got this y minus 3 equals negative 2x minus 2. What's the last step we're going to do?
I have 3 on both sides.
Yepers. So y equals negative
Negative
2x,
2x plus 1.
and that is the equation you put in. So you come right over here into your My Math Lab. You don't have to put the y equals. That's what this represents. All you have to do is put in negative 2x plus 1. Okay? Everyone okay on that?
Yeah.
Okay. Not so enthusiastic. I do want to say there is another way to do this. I talked about it in my classes. I don't really show it, but some of you have learned that you can take and you can plug into y equals mx plus b to get the equation. Okay? So again, up here, we're going to take this same point you chose and this slope, and the other way that you can do it is you can plug in this information to this equation and solve for b. So this is just an alternative if you so choose. So your y value is 3, your m is negative 2, your x is negative 1 plus b. So negative 2 times negative 2 or negative 1 gives us a positive 2 plus b. Subtract 2, b is equal to 1. And now that you know the m, now that you know the b, just rewrite the equation. Y equals negative 2x plus 1, because that's the m and that's the b. So that's just another way to do that same problem. Most high school teachers generally show you that. I used to show that method when I taught high school, and then I switched to the point slope because I have some people that mess up when they go back and rewrite this equation. Sometimes they forget to rewrite the equation, and other times they'll plug the point back in for x and y when they rewrite the equation, which is incorrect. You don't plug back in. So that's why I stick with point slope. All right. Just wanted to give you a heads up on that. Some of these problems have more than one way to do them. All right, the next one. As I talked about in my class, this is one of those most missed questions because it's like a word problem, and you all freak out on word problems. So it wants us to find the equation of a line. Okay, we're going to write it using function notation. That just means y equals function notation through the point 2 comma negative 7. Perpendicular to 5y equal to x minus 10. So remember when I talked about this in class, I had you guys set this up with a line 1, a relationship, and a line 2. What goes under line 1?
The function, the equation.
The function, the equation. So 5y equal to x minus 10. What's our relationship?
Perpendicular.
Perpendicular. What goes under line 2?
Point
The
2 minus negative 7.
2 negative 7. There you go. So this is what we now know. And this is all the information you need. Okay? So we want to write the equation over here. We want to get the equation for line 2. So what do we need from line 1 to help us out?
The slope.
We need the slope. Can you tell me what the slope of line 1 is right now?
1/5.
Say it again.
1/5.
Yeah. You got to do one piece of manipulation before you can tell me, because you have to get it so that it is y equals. Right now it's 5y equals. So this is where you got to divide all the numbers, and there's a number in front of x. It's 1 by 5. So we get y equals, and just as Rochelle said, the slope is 1/5, 1/5. And then you can say minus 2, but we don't really care about that. We just want the slope, because that's the first thing you do. Find the slope. Okay? Now, what do I do with this? What do I do with the slope of 1/5?
You put it in perpendicular.
Okay, so I'm going to transform it into a perpendicular slope, because that's the relationship. So what is the slope that is perpendicular to 1/5?
-5/1, which -5.
Yeah, there you go. -5, because the opposite of a positive is a negative. And when you flip this, you get 5/1, which is just 5. So that's that step 2. Use the relationship to find line 2 slope. And then last but not least, we are right back to what we just did on problem number 8. We have a point, we have a slope. So let's plug into point slope. All right, so y minus, what's y1?
-7.
-7. What's m?
-5.
X minus what's x1?
2.
All right. What do we do now?
You multiply the -5 by the bracket, parentheses.
All right. Bracket, parentheses, it's all the same. What happens with two negatives by each other again?
Turn a positive.
So -5 times x is,
-5x,
and -5 times -2 is,
+10.
and what's the last step?
You're gonna -7 by both sides.
So our perpendicular equation is y equals,
-5x
keep going.
+3.
And that's it. Again, if you choose to, you can do this same method with this information. Here's the x, here's the y, there's the m. Plug it into its spots, solve for b, and then rewrite the equation. So if you want to do the alternate method, you can. Your call. But again, you just come back here and you're going to put in -5x plus 3 in the blank, because that is your y equals part. Okay, moving on. Number 10. Number 10, it's just a word problem, a linear word problem, and that's okay because we can deal with that. I think this is the only word problem in the entire exam. Yes, no. There's one more right here, but that's not too bad. This is actually pretty easy, number 18. So if there's a word problem that's going to throw you off, it's probably going to be number 10. But we can do this. This isn't bad. I promise you. So it says a fruit company recently released a new applesauce. By the end of the first year, profits on this product amounted to $39,400. The anticipated profit by the end of the fourth year is $60,400. After the first year, the ratio of change in time to change in profit is consistent. Okay? So let X be years and let P be the profit, or in other words, P is another way of saying Y. So the first thing they want us to do is write the equation. Let me give you a hint on this. They are giving you 2 points here. Each sentence represents a point because there are 2 numbers in this second sentence and there are 2 numbers in this third sentence. So this second sentence says, by the end of its first year, profits on this product amounted to $39,400. What is the point that is in disguise right here? What, comma, what? What is the point? What are the 2 numbers in this second sentence?
1 comma the other number.
Yeah, 1 comma the other number. 1 comma 39,400. Because the 1 is you're in the first year. That's 1. And then comma are 39,400, which makes sense because X is in years. This is the first year, so that's X. And P is in profits, so that is the Y value, 39,400. All right. What is the point that is in disguise in the third sentence?
60,400.
60,400, but what's the first, what is that a comma before? Remember, it's a point. It's 2 numbers. What, comma, what? Sorry, say it again. You got to be louder.
4.
4. So is it 60,400, comma 4, or is it 4, comma 60,400?
4 comma 60,000.
There you go.
Huh?
So our points look like this. Because in the first year, this is how much we made. And then that third sentence says, in the fourth year, this is how much we made. All it is 2 points in disguise. Everyone good so far?
Is the point 60.400
No. It's a comma. It's a
Go ahead.
comma. I'm just trying not to make it as big as this one.
or
This is 39,400. 60,400. Okay. So all we got to do now is write the equation. We know how to do that. We did that back in problem 8. So what do we got to find first?
The slope.
Slope. So we're going to do y2 minus y1 all over x2 minus x1. So this is x what, y what?
1,
Ones. X what, y what?
2s,
Twos. So what is y2?
60,400.
Minus what is y1?
39,400.
All over what is x2?
4,
Minus x1.
1,
So now we do some subtraction. What is 60,400 minus 39,400?
21,000.
You got it. What is 4 minus 1? And then when we reduce that down, what do we get?
huh?
7,000 is the slope. Everyone good so far?
Yeah.
All right. So now all we have to do is pick a point. Which one do you guys want to work with? Actually, let's have, hold on. Let's get someone, let's go with, let's see. Which point would you want to work with?
1,39,000.
You got it, girly. Let's do it. So we're going to have y minus y1 equals in parentheses x minus x1. So y minus, what's y1?
Y1 is the 39,400. 39,400.
Okay, equals, what's our m?
2,000.
Okay. X minus, what's our x1?
1,
Okay. So now we're going to distribute through. So we got y minus 39,400. What's 7,000 times x?
7,000x.
Yay. What's 7,000 times negative 1?
7,000, negative 7,000.
Okay. And what's our last step?
You add 39,400 on both sides.
So y is equal to 7,000 x. And then what is negative 7,000 plus 39,400?
32,400.
And there is the equation for part A, because this one has multiple parts. And again, if you wanted to, you can go back and you could use the alternate method and plug into the y, the m, and the x, solve for the b, and then rewrite the equation. It works the same way. All right. So If we go back, let's take a look at what we got to do now. So that was part A. So in this blank, you'll put 7,000x plus 32,400. Okay. Now down here, part B, it says use the function to predict the company's profit at the end of the 9th year. So they got this number 9 right here. What do they want us to do with that number 9?
Gonna substitute it where the X is in this.
Yeah, absolutely. All they want us to do is plug the 9 in and tell me what the answer is. So we're going to take 7,000. Even though I know it looks like a Z, I'm sorry about that. 7,000 times 9 plus 32,400. So what is 7,000 times 9?
6.
How much?
63,000.
And then we're just going to add 32,400 onto that. What do we get?
95,400.
And this will be dollars. That is their profit. So in 9 years, they will have, I don't know why I put 94. That should be a 95. Let me grab some whiteout. Oh, Mr. Armstrong and his mistakes. All right. Let me fix that. Man, I was doing so good on this too. No mistakes yet. Even fix my little 7 up there. All right. So 95,400. Give that a moment to dry. So there's part B. So all you're going to do is come up here, and in here you're going to put 95,400. Okay? Part C says profits should reach 88,400 at the end of what year? Okay? So what are we going to do with this 88,400? What are we going to do with that? So this is our profit. We want to know the year. How can this help us out with this? How can our equation help us out with the 88,400? Hello. How can 88,400 be used with our equation up here?
Equation?
Plug that into the y and solve for the x.
There you go, Litzy. You got it. So in part B, we plugged into the x. Part C, all they want us to do is plug into the y. So 88,400 equals 7,000x plus 32,400. All right. So what do we do to solve?
Why? Oh,
How do I get?
subtract 32,400 on both sides.
Yes. Subtract the 32,400. So 88,400 minus 32,400 gives us 56,000 equal to 7,000 x. Now what?
You divide 7,000 by both sides.
And what do we get for x?
8.
8. So the 8th year is when they will hit that profit. So you just come over here and you put 8. That's it. Any questions about that word problem?
No, can you go back on it, please?
So that's the hardest word problem on there. I think that's probably your hardest problem on this exam. Okay? And we are now exactly halfway through. Believe me, when you do this exam on your own, it will be much faster for you because obviously I'm showing a lot of work and doing a lot of talking. Even though it's taken us an hour to get through 10 problems, it will go faster for you, promise. Rochelle, you're all good?
Yeah, I'm all finished.
Okay. All right, moving on. So we are on to number 11. All right, so this is where we start hitting up those relations and functions and things like that. So some of you may know about this. Some of you, we may not have talked about it yet because I know in my RTV course, we haven't hit domain and range yet. So I'm going to rely on some of my other students in here. All right, so it says find domain and range, okay? Give you a little hint. Domain is the X values, range is the Y values. So if we look at this, what's the domain of this function going to be?
You said domain is Y.
Nope. Domain is X, range is Y. What is the domain of this function going to be?
-2.
Or sorry, I don't know whether it's a function or not. Just the domain of this set, I should say.
-2.
Okay.
It doesn't matter the range. The order, right?
Normally when we write sets, I like to put them in order from least to greatest. Again, it looks like for this, they just say separate the answers with a comma, but you should put sets in order from least to greatest.
Okay. -8.
-8, because that's an X value, comma.
-2, comma -2,
-2, because that's an X value,
comma 5.
comma 5. Good. And we do not repeat values. Once you say -2, it covers both of those. Okay, there's the domain. -8, comma, -2, comma 5. Done. That's what goes in the blank. Range.
-7,
So -7, comma.
comma. It says smallest, right? 3.
3, comma.
6.
6. There's your range. Now, the ultimate question, I accidentally called this a function earlier, and maybe it is a function, maybe it is not. So the last question is this a function? And the way that you tell functions, anybody remember? Let's see, hopefully you might have seen the video to this by now. Mariana? Huh?
If the X doesn't repeat, it's a function.
There it is. X's don't cheat. So you look up here, you look at your X values. If you see an X appear more than once, not a function. So are the X's cheating?
Yeah.
Who's the cheater?
-2.
-2. So this is not a function. Because in order to be a function, X's don't cheat. And right here, we got -2 going to 3 and -2 going to 6. Player trying to get away with it, but not. All right. Question number 12. Moving on. So in the blank up here for domain, you'll put -8, comma, -2, comma 5. In the range, you'll put -7, comma 3, comma 6. And down here, you'll select no. All right. Number 12 says, use the vertical line test to determine whether the graph is a function. So I'm going to make a horrible looking graph on my piece of paper with our oval Yeah, that's ugly. But there it is. So the vertical line test says I draw in lots of vertical lines. And let's see. Do you remember what happens if a vertical line hits the graph 2 or more times? Is that good or bad?
It's bad.
It's bad. So if I draw on vertical lines and I hit my graph more than once, 2 or more times, it is not a function. So I draw on a vertical line. How many times did I hit my graph?
1,
How many?
1,
Rochelle, you're mumbling a little bit. I can't quite pick up the number.
1.
1? No. How many times did I hit my graph here?
Is
Here's
it
my
first one?
graph.
1.
No, I didn't hit it once. How many times did I hit this oval with my vertical line?
Oh, twice.
Twice. 1, 2. So is this a function?
No.
Not a function. The moment you hit your graph more than once, you're not a function. All right, moving on. Number 13. There we go. So you would come back here and you would say no. All right. So again, another vertical line test here. So let me draw my ugly graph of this as best as I can.
Mhm.
All right, here it is. So if I draw in vertical lines, there's one, there's one, there's one, vertical line, vertical line. God, that's a horrible vertical line, but vertical line. How many times are my vertical lines hitting my graph here?
Multiple.
I know it's hard to see, but this was my original y-axis. This is my original x. How many times am I hitting it?
Multiple.
1. I only hit it one time. I only hit it one time. I only hit it one time. We'll do this. This is my x. This is my y. This is my y-axis. This is my x-axis. So that way we know. So we only hit it one time. We only hit it one time. We only hit it one time. So is this a function? Say it again.
No.
Why? I'm only hit my graph one time.
One time? I don't know the difference.
Well, there's only one circle on this line. There's only one circle on this line. There's only one circle. Do I have any of these vertical lines where I have
Oh,
two?
so the thing you draw on the graph, that's what you're talking about.
Yes, my vertical lines. So as long as I'm only hitting one, is this a function?
Yeah.
Yeah. Function. The moment I hit my graph twice or more, not a function. So you just come over here and you say yes. Okay, number 14.
Number 14.
We've got 3 equations, f of x, and this is what we call function notation. It's just a fancy way of saying y equals. So we got f of x equal to negative 3x plus 4. We've got g of x equal to negative 4x squared plus 4x plus 4. And we've got h of x equal to 8x squared plus 3. And they're asking us about this h with the 3 inside the parenthesis. So what are they wanting us to do?
To substitute 3 for x.
3 for x. Where? I've got 3 equations.
H.
In the h.
Yeah, you got
equation.
it. Yeah, Kelsey, you got it. plug it into H, because this letter tells you which equation to look at, and then all they want you to do is just plug 3 in. So we're going to take 3 and plug it into this guy right down here. That's the equation you're going to use. So H of 3 is equal to 8, 3
Open
squared
bracket, 3
plus
squared.
3. And now you just do some PEMDAS. What's 3 squared?
9.
So we're going to have 8 times 9 plus 3. What's 8 times 9?
72.
72 plus 3.
75.
There's the answer. So all you're going to do is come back to your test, type 7, 5, done. Everyone good?
Can you go back to the
Yes, I can, Stephanie. So they give you 3 equations. You got to make sure you plug into the correct one.
okay, I got it. Thank you.
You're welcome. All right. See, the second half of this test goes by like really, really quick. It's your first half, questions 1 through 10, that take you a little bit longer. All right, number 15.
Mhm.
So we are asking about the domain of this function. Problem is that this domain is a little different because you are actually looking at an equation. So you do not have a set. Okay? All right, so let's talk about this. When I have this equation, okay, when I'm looking at equations, when we talk about domain, the very first thing you're going to assume is that the domain is all reals. Everything is good to go. So every x value is a-okay. Unless we have one of 2 types. Unless it looks like what we call a rational. Rationals look like fractions. Or it has a radical in it. A square root, in other words. So if we look at this right now, my domain is all reals. Unless it looks like a rational, which looks like a fraction, or it has a radical, like a square root or a cube root. Okay? So when I look at this, does this look like a rational? Does it look like a fraction?
It's a fraction.
Yes. This is what we call a rational function, which we will explore in much more detail later on. So that means our domain is not all reals. So you know right away your answer is not B. It's not every real number. It's going to be A. Okay? So let us figure out what we have to put in that box. So when you have a rational, what we care about is when the denominator is 0. Because remember, we talked about this, that our calculators do not like it when we take numbers divided by 0. It gives us an error. And it says divide by 0 because we can't do that. No 0 in a denominator. So in order to figure out this domain, we need to figure out when this creates 0. So to figure that out, all we're going to do is take the denominator and set it equal to 0. So we're going to take 4x plus 8, set it equal to 0, and we're going to solve. So let's get x by itself. How do we do that?
Minus 8 on both sides.
Yay. What's 8 minus 8?
0.
Negative 8. And then all we're going to do is divide by 4.
X equal negative 2.
Yes. So this is the number that makes 0. So that means this is the number that we don't like. So when we write our domain, we write this answer, but we put a slash through the equal sign because we don't like it. Because this is the number that makes the bottom here, the denominator, 0. And as I showed you on my calculator, that's bad. So that's the domain. So when you come back to your test, you're going to select A, and then all you got to put in here is put the number you found, -2. Everyone good on that? Okay. 16. Again, another domain question. So let's take a look at this one. And this one is actually just the multiple choice. So you could actually take you got a 1 in 4 shot of getting it right if you guess. But we're not going to guess because we're going to know the answer. So right now, looking at this, I assume my domain is all reals. Every number works. Unless it is rational. So does this look like a fraction?
No.
No. Okay, so right now my domain is still all reals. Unless it has a radical. So does this have a square root or a cube root?
Square root.
Yes. So now we know our domain is not all reals. So it's not going to be the negative infinity to positive infinity. Okay? It's not this guy. So in the case of radicals, what we do is we take the piece under the radical. It has a name. I can't ever remember what the name is. I think it's like radicand or something like that. But we take whatever is under the radical and we set it, and I just call it the polynomial. And we set it greater than or equal to 0. Because as long as this number is 0 or positive, we can take the square root of it. Because if you go to your calculator and you try to take this, see, it should show you some things. Square root of 0, see, 0. Square root of any positive number like 6, see, we got an answer. It's not the nicest answer, but we got one. But if I take the square root of a negative number, like say -1, error. It doesn't like it. So that's why we take and we set this piece greater than or equal to 0, because these numbers work under here. Because as long as you're 0 or above, you're good to go. So all we're going to do is take this polynomial here, which is x, set it greater than or equal to 0, and solve. Do I have to do any solving?
No.
No. But we do need to write this answer up in interval notation. We need to write this answer up in interval notation. So interval notation, if you kind of make a quick graph of this, going back to what we had, 0's in the middle, it's a bracket, and we shade to the right. So what does this look like as interval notation?
Bracket 0 to positive infinity.
There you go. That's the answer you want. Okay? So we come back, and you will select what would be technically choice C. That guy right there. Any questions on number 16? Okay. Number 17. So this one is a little bit hard for me to reproduce on my on my piece of paper, so we're gonna have to look at this one right there. So there are two graphs. What is this function's name right here? What letter represents the blue function? Look carefully at the picture. There's a letter in there.
F.
This is F. It's right there. What letter represents the red function to the right?
E.
G. So just like before, you had three functions. This time you've got two. So you're only going to pay attention to one of these. Okay? So here it wants to know what is the answer for f of -1. So first, which function are we going to look at?
The blue.
The blue one. Who does this -1 really represent? Remember, if we had an equation like these, where did this number go in for? Who does it represent?
X.
That's X. So just to kind of talk to you a little bit about this. This guy is X. They want you to find Y. So in other words, they're asking you, what is the point when X is -1? They want to know why. Does that make sense? They're telling you what X is. They want you to tell me what Y is. So we go back to our graph. X is -1, so that's right here. Where's the point? Where is it down at? What number? What's the Y value? What is it?
-5.
It is -5. There you go. That's it. That's all you're going to do. In the blank, you're going to put -5 because that's where the dot is, right here at -1, -5. Everyone good so far?
Yeah.
Okay.
I don't
You
get
okay? Remember, this is the X value, right? So we're on the F graph. So here is -1, right? Now, where is the graph at? Where's the Y value? Right there.
Below it. Yeah.
Below it. And what number is that at? If you count down, that should be what number?
1, 2, 3, 4, 5. 5.
So it's -5. That's the answer. You okay on that now?
Yeah, sorry, I was dozing
It's
off.
okay. This is telling you the X. They just wanted to know the Y value. All right, number 18. Number 18, this is another word problem, but you got this, I promise you. So it says, the dosage in milligrams D of a heartworm prevention or preventative for a dog who weighs X pounds is given by D of X equal to 136/25X. Now, I know many of you see the fraction and you're like, oh my God, what am I going to do? You got a calculator, sillies. We're going to use it. Okay, so it says find the proper dosage for a dog that weighs 34 pounds. What are we going to do with this 34?
Yeah, put it where the X is.
That's it. That's all this problem is. It's a plug and chug. So they're telling you that X is 34. Plug it in. So D of 34 equals 136/25 times 34. And we're going to get our answer. Now, let's take a look real quick. It says your answer should be an integer or a decimal. So no fractions on this. So just go to your calculator. Where's my fraction keys at? How do I get my fractions? Come on, where's our best friend? Where's that best
Alpha
friend?
Y.
Alpha Y. And it's right there. It's number 1. Hit enter. And we're going to put that 36 over 25. And then we're going to scroll out to the right of it, put our parenthesis, 34, parenthesis. And there it is. It's the same way I have it written on my paper. See? And then hit enter. Boom. There's the fraction. Uh-oh. How do I find the decimal for this?
How many times?
How am I going to find the decimal?
Isn't it going to give you a function?
Say it again.
Isn't it going to give you a fraction and if you do it like that?
Well, I got a fraction, but how do I get the decimal out of this? Oh, you all are thinking too hard.
Divided by the 25.
Yeah, just divide. Take 4, 6, 2, 4, and actually divide it by 25. All a fraction is division. There's our decimal. And that's
184.
184.96. They want the whole thing. It does not say round, so do not round. So in here, you're going to put 184.96. Make sure you read that fine print because it'll tell you if it wants you to round or not. Okay. Last but not least, number 19 to number 20. These are not crazy ones. They just want to know, if I give you this function f of x equal to x squared, which picture down below is that function?
A.
It is A. And again, you can go to your calculator because just remember, this means y equals, right? So I can go to my calculator and I can actually put that function in if I don't know what it is. I can put x squared, graph. Oh, that looks just like A. Okay, so on these last two, you can go straight to your calculator, graph it real quick, and then pick your answer. And last but not least, they tell us number 20 is f of x equals x. Which graph below is that one?
C.
C. Yay. Because again, you can just go straight to your calculator and put x and then graph. There you go. Okay. And that is exam 1. That's all you need to know. Nothing else. And I have the answer key all worked out right here, which I'm going to upload here in a second. And this video, oh my God. No, I did record. I almost forgot. I thought I forgot to record. And this video, once I get the link to it, I will post it on the math resources or online math resources for students Canvas page. Any last minute questions, comments, or concerns? Okay. So I'm going to stop recording.